labor. These things are super hard to measure, right? So you will find papers that tell you this all still holds, but you will also find papers that tell you this is not holding anymore, right? I mean, in the end, you have to make up your own mind. But maybe just to give you this one example here, right? Maybe some of you have like seen that, heard of that, maybe even read that book, right? Kind of at the time, this famous book by Thomas Piketty. And I mean, this is one of the points that he made, right? He was basically, I mean, what he did was like to really compile long-run data. And the one thing that he looked at, I mean, he looked at different things, right? But the one thing that he looked at is this fact 5, right? Is it really true that the capital and the labor share are stable over time, right? And I mean, he relates that then to inequality, because that's the way of thinking about this, right? So what share of output goes to capital, what goes to labor, right? And I mean, this is exactly what he's doing, right? So he looked at this capital share, right? Yeah, and now this is now interpreting data, right? Which can be cumbersome. Is that stable? What do you see? What's happening in that data? That's the Piketty data, right? So I just stole the figure from like this website. Is that stable?
It increases, I would say.
Yeah, it looks like it's increasing, right? I mean, it's a bit hard to see, right? But I mean, this up here is like, this is Italy. So where is Germany? Germany are these triangles. That's super hard to see in this figure. The US is a bit easier to see. This is these numbers. But there seems to be an upward trend. And that's basically Piketty's message, right? So he's telling you this increase in inequality, this is where it's coming from, right? That we like kind of like the returns on capital have become more important, and this is kind of this inequality, right, between capital and labor, right? This is exactly where this is coming from. But first of all, note that this level that I gave you on the earlier slide, right? So you guys said this is around 1/3 the capital share. This is kind of where we are here, right? I mean, again, this is always like, depends exactly how you compute it. There's some things, right? But this is the order of magnitude where we are, right? But he also documents kind of an upward trend. So, I mean, as always, right, the empire strikes back, right? I mean, this year is 2014. There have been many people criticizing the way how we compile this data. So there have been people arguing that this is actually not true, what you see, right? So I don't want to like say that this is the only message that you can get, but just feel free to look at the data yourself. But I mean, obviously, this figure starts in 75, right? I mean, Piketty also has figures really starts like in the 1900s, and we can make long discussions about this, right? But this is interesting numbers, right? Just to say that. So, long story short, I would say there is a bit of a question mark here, right? It has also been discussed a lot based on US data, and I mean, what you can see pretty clearly in US data, that there is a fall in the labor share. So typically the labor share is more easy to measure, right? Wages is something we do observe, right? Capital and returns on capital is always much more difficult. Labor wages is something we can measure, right? And then in the recent year, you do really see this decline in the labor share in the US. For Germany, it's not so clear. I've actually just recently seen a paper. There were like some papers arguing that we do see this. Recently, I've seen some evidence that this is actually not true, right? So this is an open discussion, I would say, right? Whether this is happening, yes or no, right? But yeah, so there are some question marks on these type of aspects, right? So this is number one. And number two, we basically already discussed, right? This is about this fact one. Is it actually true that this growth rate of GDP per capita is still constant in industrialized countries? And more people have argued that it is actually not, right? So here Gefei-FIONA is one prominent example of that. So you can also just go on his website. This is actually a blog entry where he argues exactly that. He's actually written a book. The book is called Fully Grown, right? So I mean, they already see the hypothesis, right? Is it that we are so rich now that we are not growing anymore because maybe also preferences has changed, people just don't want this anymore? This is kind of his line of arguing, right? You just see the data, right? I mean, here that data looks pretty clear, right? Because it kind of supports his hypotheses. You can also interpret the data a bit differently. You can also say, okay, I mean, this is Europe, right? That we were growing a lot here, is not surprising, right? This is just after World War II. Obviously, we were rebuilding everything here, right? So this directly feeds into GDP growth. So maybe this year is a particular period that we shouldn't interpret. And also here, I mean, this data here stops in 2010, so you have the financial crisis in here, right? And now we're back basically to this, what I just raised before. You cannot completely disentangle trend and cycle, right? If you have a huge recession here, obviously that brings down your average growth rate. And is that representative for the longer growth? I don't know, right? But that's up to discussion. I mean, he puts that completely in. It's not clear that you should be doing this, right? If you would take that out, then it would look more stable already, right? So this is always, yeah, as I said, I'm asking questions, I'm not giving you all the answers, right? I just want to show you the discussions where we are, right? But this hypothesis, right, that there is this slowdown in growth rate clearly is there. Right? This is basically what you have on this slide. Yeah, this is these two things. Maybe two other arguments, right, why this could be true. The one is that some people have actually attributed this slowdown in growth rates to market power, to increasing market power. So I got some data, there's one example, right? So think about Amazon, think about Google, right? These large firms taking more and more market power, and I mean, there's good evidence or good reason to believe that competition is good for growth, right? This is basically what every growth model will tell you at some point. Competition is good for growth, right? And this was also basically just our Nobel Prize, right? If you want to have innovation, you need firms to compete, some firms will go out, right? This is creative destruction, right? If you have an increase in market power, you're basically preventing that, right? You have some large firms, you have grants, you have profits going up, but this is not good for growth, right? I mean, that argument is actually not new, right? But basically what these people did is to relate it to the current situation. The other argument is a bit about the secular stagnation story. I mean, this word already sounds a bit like this, right? Are we now entering a period of low growth? So this comes more like from the financial side, as to say, right? So they basically relate this to a decrease in interest rate, which you can also relate to demographic things, right? So if people save a lot, you've heard this term, the saving glut, where they're basically saving too much. It also related to government debt. So all these things, right? So this is just another hypothesis which could explain this, right? And I mean, the arena is open, right? It's really not clear what it is. We need more evidence, so right? So, yeah, questions, thoughts?
What are the main arguments against the message from Piketty? Like, he is saying that capital share increases?
Well, I mean, the main, I wouldn't say there's a main argument. I mean, it's just that some people have basically argued that if you treat the data differently, it's not that clear that you actually see this downward or this upward trend in the capital share, right? So it is really, I would say, just this overall message is a bit up to discussion, right? So I think what is well established is this fall in the labor share in the US. That's clear in the data. I would say that's my interpretation.
But not worldwide.
But yeah, that's much more difficult, and also depending on the time frame, right? I mean, he basically relates that he goes back to 1900 something, right? Yeah, so it's just that's just the point, right? So it's not so clear whether that's actually in the data or not, right? And I mean, he makes this very strong claim, which is also a political claim, obviously. I mean, what Piketty was saying is, this is why you should profit, and that this is why you should tax capital, right? That's basically his message. I mean, I'm not judging the message, right? Maybe you should, right? It's just, he has this very clear political implication. And also on that, obviously, you can discuss, right? I mean, there could also be other ways to address this. So, yeah.
Another question, aren't all these facts contingent on each other? So if one is shaken up, then 2 and 3 also get weird and stuff?
Yeah.
So doesn't it mean that they can always very fast?
Yeah, I mean, this is economics, everything here can break apart, right? This is not physics, right? We're not writing down any like rules that will hold forever. So yeah, in principle, yes. I mean, you're right, right? I mean, if this thing here doesn't hold, this also means something for this and this. This is right, yeah, definitely. And I mean, but this maybe also explains why, I mean, these different, if you would ask Vollerath, right, he would basically tell you it comes out of preferences, right? So he thinks about households, he thinks about consumption. If you think about secular stagnation, these people actually start here, right? Piketty maybe starts here, right? Yeah. Okay. I think that's what I said, right? So that's my main message of this chapter 1. I just want to like throw some of these dialects facts at you. And I mean, you should kind of, like in terms of what you want to learn, right? I want you to understand what this HP filter is, and what are these most important stylized facts, right? And this includes these long one and these short ones, right? More questions? Maybe also going back to your question, right? I mean, here one depends on the other, absolutely, right? And I mean, this is kind of what I want to do now in the following, right? So this was my most data-driven chapter, right? What we will do now is we'll move to theory, right? And I mean, this is kind of, at least my understanding, right? If you want to like really explain this, you need a theory, right? And actually, you do not just need one theory, you maybe need different ones, right? And every theory will give a different view on this, right? Will help you to understand this, right? And this is what we have before, right? Going back to my point from last week, right? Every model is wrong, but somehow useful. So this is just it, right? If you want to make sense of it, try to like make that in a consistent way, and this is what I will try to use our models for.
How do I try to attempt to explain the large difference in growth rates between, yes, I'm assuming it's developed countries here, or did he just say that they exist?
His answer is I don't know, but I don't think he did. No, no. This was really just more like a summary of these facts. Yeah, and I mean this is completely up to so we get back there, but it's also not like you have one answer, right? It's I mean, obviously, it all depends on where you are, right? But this is exactly what you will see in our growth models, right? Is it that you're kind of basically like on a growth path, like that you're already fully grown, right? That would be this Vollerath story. Or is it maybe that you're still like on this catching up part, right? I mean, this is like, if you think about these Southeast Asian countries, this is very often how we think about their strong growth rates, right? Because they actually like do more or less catching up, and this is basically what I've shown you with Europe after World War II, right? So in a way, this is just very normal growth, but that this growth is not sustainable is also clear, right? Yeah. Good. If you want to open a window for a second, I don't know how you are feeling. Thank you. Good. Yeah, so as I said, right, this was kind of my introduction. And now I kind of want to like dive into all these models that we have to think about this, right? So what I want to do today, or start today, is like this, like my tour from old to modern macro, right? So where am I actually heading to, right? I kind of want to explain that a bit. And just to make sure that we have everybody on board, I will actually try, or like go back a bit to probably ISLM, right? ASAD. We will also go back to the solar model, right? And I mean, basically just to say that, I mean, as far as I remember, many of you said that you kind of have a background in econ and an undergraduate, right? That sometimes like people have different, like, what they actually focused on, right? So if ISLM ASAD does not ring a bell for you, look it up, right? I will give you a very short tour now, but I cannot like do the full tour because that would take us too long, right? But if you go like, I don't really remember what that was about, I would strongly suggest that you do a bit of reading, right, on this. Same for solo, but read it there, right? So what I want to talk about a bit is why did we move away from ISLM, and what's the crucial parts, right? So what we are doing differently nowadays, right? And this will then exactly lead us to what we call modern macro. And like the second part of this chapter will focus a lot on the solo model, which is a growth model, right? Which kind of the solo model is to a large degree the foundation of everything that will come later, right? So it will be very important to understand the solo model because the solo model is like the model for capital dynamics. Sometimes say the solo model is the model of capitalism. It basically is, right? And this is kind of what's coming later, right? And this is why this will be very important. Right? Okay, if you want to do some background reading, as I was just suggesting, right? I mean, on an ISLM, you can basically use any undergraduate textbook, right? It's always covered there. You can use the Menke, you can also use Bloch-Scheiling, it's all there, right? On the solo model, I mean, the Achimotto, that's the textbook that I basically recommended you here, covers that, right? It's also his chapter too, so he basically also starts from there. Okay, so yeah, let me give you this very short, I hope, reminder of what an ISLM is, right? So the ISLM is basically the model, right, that we were using, I don't know, like in the 70s, 80s, right, to think about macroeconomic policy, to think about monetary policy, fiscal policy, right? It is very typically the model that we teach in an undergraduate, right? Because it has the main advantage that it is relatively simple, right? It is a macro model, it is relatively simple, and it allows you to think about questions like monetary policy, right? So this is why it is nice, right? Because it has this very clear predictions, right? But what it does not do, and I mean here I'm basically already flagging that on the first slide, is the ISLM is a summary of ad hoc equations, right? So basically you're just describing behavior of agents by putting in an assumption, right? And this is exactly what we have moved away from, right? I will show you exactly what we mean by that, but this is like kind of what it does, right? So these models are not about microeconomic behavior of agents, right? You're just basically putting in aggregate behavior for everyone. Okay, so here's my refresher. So what is ISLM? So IS is investment saving, right? This is basically our way to think about the good market, right? Demand in these models, right? That's the good market. So in an ISLM, this is the maximal simple way to think about it, right? It's basically a Keynesian style model in that sense that prices are completely fixed. This is a completely short-run perspective, right? Very short run, prices are completely fixed. This is this famous equation, right? Output equals consumption, investment, government spending. I'm missing the NX because this is a closed economy here, right? Just put NX to 0. And this is exactly these behavioral things that we're just throwing in, right? We nowadays call this reduced form, right? So basically what we assume is very simple. You just say, okay, aggregate consumption in the economy, let's just say this is always this fixed share, C1, of income, so we call this disposable income of households, right? Income minus what they have to pay in terms of taxes, and they're always consuming this fixed share, right? And this fixed share, this is the C1, this is this famous marginal propensity to consume, that is the core of these models, because this will then determine your government spending multipliers, basically all these actions in these models, right? So this C1 is very important, right? But it is basically a number that's just assumed and you're just putting that in, right? Typically also have this C0, which is basically where you assume this is the consumption that we always have, even if there's no income, right? Because you have to eat. Okay. Which gives you this positive relation, right? If output increases, if there's more production in the economy, people will demand more, right? And this is kind of this Keynesian idea, right? Demand plays a role, right? And on the other hand, you have this famous equation for investment, which looks super simple here, right? Basically just, again, you're just like putting that in, right? Investment is a negative function of the interest rate, right? So this is this idea, when the interest rate goes up, it's actually more expensive for me to invest, right? And this is what I'm able to do that. Okay, this is the IS, I demand, if you want so, right? The good market equilibrium. And on the other hand, you have the money market equilibrium. This is what we call LM, for liquidity equals money. Which basically, again, kind of this Keynesian, going back to these Keynesian ideas, right? Money supply equals money demand, right? We typically call this L for liquidity, right? How much cash do I actually want to hold? And the idea here is just, if you increase the interest rate, right, it's actually, I should not hold as much cash because I should better put my money in a bank account, right, because I would actually get the interest rate, right? So this is where this negative sign comes from. But if my income increases, I actually want to buy more, so I will need more cash, I will need more liquidity, and my demand for money goes up, right? Okay. And I mean, what this gives you is this famous thing here, right? So this ISLM's cross, right, in output and the interest rate, right? And now we can do this policy analysis, right? And I mean, this is exactly what we have the model for, right? And you can basically do, this here would be expansionary monetary policy, right? So the standard model thinks about an increase in money supply, right? So you could say the central bank increases money supply, goes up. And what happens in this model here is that this shifts down the LM curve, right? So there's suddenly more money, provided this shifts down the LM, the interest rate falls, right? This is the money market. And now, and I mean, that's now what makes this a macro model, right? This now feeds back into the goods market. People will respond. And why they respond is exactly this, right? So if the interest rate falls, people will invest more, right? Investment goes up. This increases demand. This increases, because investment goes up, right? This increases production, right? And this is, I don't know if you remember this Keynesian cross story, right? Once production goes up, this is then when consumption goes up and you get these Keynesian multipliers, right? And this is why output will go up, right? So production increases, GDP increases, right? So that's just like a very short tour, right? Monetary policy reduces the interest rate and that increases output, right? And this gives you one way to think about why a central bank can actually affect output, right? Production in the economy, right? So, again, very short tour, right? I'm super simplifying now, right? I mean, first thing you could argue, central banks do not set money supply, which is true, right? We'll get back there in a second, right? They set interest rates. There's lots of things, right, which you probably have already discussed in an ISLM, right? But this is the main message, right? And I mean, to me, main message always being, think about this as two markets interacting, right? There's something happening in the financial market on the money side here. This has feedback on the goods market, means something for demand, means something for production. And this then actually feeds back into the money market again, right? And this is this back and forth, right? And this is basically what makes this a general equilibrium model, right? So if you use two markets interacting, and this will show up again, right? I mean, this is also happening in our other models, right? Basically, we will not call this IS anymore, but you will see that in most of our models, something like an IS also falls out, right? Monetary policy admittedly looks very different in modern models, right? We get there, but it's still there, right? So this whole idea is just, it's still there, right? And this is also why I like to start with this, because I think just understanding that will also help you to kind of understand like the key message of later models, right? Which will be much more advanced in terms of math and equations and whatever, right? But lots of that goes through. Okay, so yeah, maybe that's what you can check at home, right? Try to answer that question at home. What happens after an increase in government spending? If you can answer that, I think you're well equipped and you understand the ISLM again, right? You could do the same thing with the ASAD. Again, I want to be short here because I want to go into like what we actually want to do, right? But maybe you can also have a look at these slides, right? I mean, what's the difference in ASAD? Basically, what you do is now you say, let's consider a situation where prices are not completely fixed anymore, right? So we make prices flexible again, so that we can actually talk about the price level in the economy. The ASAD does not really allow you to talk about inflation a bit, right? But it goes like half a step there, right? To think about inflation, which obviously is not a macro level that matters, right? That the ISLM does not know. But in the end, the model is similar, right? You also have a demand curve, and I mean, this AD basically folds out of the IS, right? The idea is exactly the same. So this is the idea, the AD, aggregate demand, and you have aggregate supply, which is either fixed in the long run, or you basically have this short run upward sloping, and I mean, there's different stories you can tell. But again, models that we will be using later typically provide, for example, micro foundations for this upward sloping short run aggregate supply, pretty advanced micro foundations. And I mean, this is, at least I don't know how you experience that in an undergraduate. We talk about the AS curve, but we never really say where it actually comes from. The reason is that in these models you basically cannot, right? You just have to put that in. I will show you how we can actually make the argument formally, but for that you need a bit more, right? But again, this idea of different curves interacting, that's also what happens later, right? Okay. So this is again why I think, like, going back to this, if you've not heard of this and you're not completely comfortable, again, here's a question how you can check yourself, right? If you can answer this question, I think you're well equipped, like, for the remainder of the course. Good. So, but now let me go there. Why we want to do more, right? Why do I not want to stop there, right? And I mean, the list of reasons is long, right? I mean, one of them I basically already talked about. One major critique to the ISLM is that in the ISLM, if you think about monetary policy, the classic model thinks about money supply. No central bank nowadays uses money supply as an instrument. They all use interest rates, right? To me, actually, it's kind of a cheap critique on the ISLM because you can actually introduce interest rate targeting very easily in an ISLM. It's not like this is not doable, but you have to do a bit, right? But this is one of the main things that also showed up like in the literature, and I mean, newer models all like do this differently. Basically, money supply doesn't really show up in modern models, to be honest, right? This thing kind of disappears and there's good reason why, right? One other like critique that you see a lot is like the ISLM predicts this very large fiscal multiplier, right? So like basically, if you think about the Keynesian cross, you get a fiscal multiplier of around 5 if you put in a marginal propensity to consume, or MPC of around 0.2. And I mean, there's evidence for fiscal multipliers, right? So there's empirical evidence. There's also evidence that fiscal multipliers can be larger than 1. Maybe they're even 2. But I've never seen credible evidence that a fiscal multiplier would be 5, right? It's just like, I mean, yeah, it is like some stuff like falling out of these models, which is clearly, you would say, counterfactual, right? Yeah, right, so these are like kind of practical things, right? But then there are like two major, we call these critiques nowadays that came up, right? In the end of two different persons, both of them have been awarded a Nobel Prize at some point, right? So the first one is what we call the Lucas critique, and the second one is what we call the Sims critique. Maybe let me start with the second one, because on the first one I will actually talk a bit longer later. So basically what Sims did, it's actually this paper is interesting. I mean, again, right? Feel free to open this. I'm not certain, I'm not citing this. Like Sims 81, it's probably somewhere in the slides later. If you read that paper, it's really like, he's basically saying, and he does say it in pretty plain words, hey, what you guys are currently doing is just nonsense. he's really saying that, right? So it's a pretty strong critique of what like these ISLM models and stuff have been doing. He argues mainly on empirical points. So basically says you're just like using aggregate relations in the data, right? So basically, go back here, So what people have been doing, just use the correlation of GDP and consumption maybe to feed this thing here, right? And that's nonsense, right? I mean, I think that's basically what we all would agree nowadays on, is that using such a relation to like empirically validate these models is just not a good approach, right? And he makes that very clear in that paper. Why he thinks it's nonsense. So that's the so-called Sims critique. And the major one, and I mean this is basically what we nowadays talk about a lot, is what we call the Lucas critique. So about Lucas. And this is what we nowadays call this lack of micro foundations. Actually, these two things are also related, but let me focus on this. Basically, it's also, what he's doing, he's also criticizing this thing here, right? So he's basically saying just assuming this here is not a very good idea, right? This is not how people behave, right? And let me just give you one example, because I think that makes that very, very clear what I mean by this, right? So here's basically this, formal argument of the Lucas critique, but let me start with the example, right? I bet most of you have seen this Phillips curve relationship in your undergraduate, right? So the Phillips curve is, again, this is an empirical paper, right? Also based on British data at the time, because that was the data that we had, right? So Phillips, what he did was to just relate the unemployment rate to inflation. He actually looked at the change of wages at the time, right? Nominal wages as a measure of inflation, right? And what you see is this negative relationship, right? Kind of this famous Phillips curve story, right? So which basically led some people to say, yeah, either you have high unemployment or you have high inflation, right? Basically this trade-off story, that's the Phillips curve, right? And I mean, what's interesting is that this Phillips curve sometimes shows up in our models too, right? We'll get back there, right? But this is first of all an empirical relationship, right? So this point was made here in 58, right? Until some people got really to know this was like 60, 70. And then there were the oil price shocks happening, right? And then we actually entered a period where we had both at the same time, right? After the oil price shocks, we had large unemployment and large inflation. And this Phillips curve relationship completely broke down in the data. Some people even say it broke down a bit like because policymakers tried to exploit this, right? So maybe they were like, if you go loose on monetary policy, right, let's just increase inflation, who cares? As long as this reduces unemployment, it's all good, right? But it turned out in the data that this was not happening, right? Basically what happened was we were increasing inflation, but at the same time unemployment increased too, right? So this trade-off that this empirical relationship here suggests disappeared, right? And I mean, maybe this kind of reminds you of the discussion that we're currently facing in the US, right? If people in the central banks basically like, be really careful to exploit this thing. It's basically, again, this discussion coming, right? It's just not, but just increase inflation in the long run. I mean, this is just it, right? It's reappearing, right? Good. So, but I mean, like, what would Lucas tell you why this broke down? He has a very clear story, right? So he would basically tell you, yeah, because people are not stupid, right? This relationship only holds as long as, and now I'm using these words that we use, as people believe that inflation expectations are low, right? Only if people believe that we are in a sort of like a world where inflation is well anchored, it is maybe around 2%, whatever, they will act accordingly, and then you will see this relationship here, right? But once people understand that actually the central bank has fundamentally changed its behavior, we see now in the long run, on average, larger inflation, they will act accordingly, right? And then this relationship here breaks down because they will basically not be, in a way that's also right, deceived by that, right? This relationship here only works because basically inflation was higher as you expected by surprise, and this brought down the real wage, for example, right? So then this works. But if everybody knows that inflation will be high, they will like put their wage contracts accordingly, and then this thing here doesn't work anymore, right? And that's, I mean, in plain words, the simple argument that Google made, right? People are not stupid. They will care about I mean, he basically says forward-looking behavior, expectations, right? So in a way, let me just go back here. He basically says this here is nonsense, right? Because people will not just make their consumption choice based on their current income, but they will, for example, make their consumption choice respective to their expected future income, right? So this goes back to like what we call these different consumption hypotheses, right? What do I actually care about if I like decide on what to buy, right? Is it my current income or is it what I expect to get in the future, right? I mean, obviously, like the reality is always kind of in between. It's a bit of both, right? People will also be different, right? But here you're completely ignoring this forward-looking term, right? And I mean, this is super extreme, right? And that's basically the point. So like in more, that's just what you have here, right? This is not forward-looking, right? So like using more like his words and like how we nowadays think about this, what this implies is that these models were lacking micro-foundations. And what we mean by micro-foundations is exactly this, right? If you are a forward-looking agent, right? And think about consumer here, right? Just think about yourself, right? And there's now a central bank doing something completely different to before, right? They're reducing the interest rate, even though actually the data doesn't look like interest rate should be reduced. So then what's happening is that these people will adjust their behavior accordingly, right? They are not stupid, they will adjust, right? And this means that they will put, I don't know, contracts differently, they will consume differently, right? They basically will change their expectations about the future, right? And then this thing that the policymaker, in my example the central bank, right, but it could also be a fiscal policymaker obviously, will be completely misled, right? So then what he's doing is just not working anymore, right? It's basically a simple argument, right? And then, I mean, that's the critique, right? That's just not how you should do it. But Lucas, and I mean, this is why this is so prominent, right? He actually makes a point how you should do it, right? So what you should do is to really think about the individual behavior of each and every one of us. This is what we mean by micro-foundations, right? To really think about how does a single person make a consumption decision, right? And then forward-looking terms will show up. There's actually an optimization going on, and this is exactly what he asked for, right? We call this like the deep structural parameters. It will all matter, like on the household size, it will all depend on your preferences, right? How risk averse are you? Are you confident to go to a bank and ask for a credit? Well, maybe if your income drops, who cares? But there's a bank which just gives you a credit, right? Then I just keep consuming as I always do, right? There are people that do this. And then there are also very different people who would never do this, right? They just reduce their consumption, right? So that's basically all these things that go on. Okay, so then what we have to do is, right, we have to get these micro foundations, but this is still a macro model, right? So then what you need to do is you have to like come up with the micro foundations and then aggregate them up again to the macro model, right? And this is exactly what we do in these models. Okay. Questions, thoughts? This is basically what I said, I think, right? Maybe to give you some more words on what micro foundations mean, right? Because I sometimes have the feeling that this is a bit also misinterpreted, right? So micro foundations really is, right? You want to think about consumers, you want to think about firms, right? This is what our models will do. I will show you firm problems, I will show you consumer problems, right? So it's a lot of micro, right? So this is what we do, right? Typically, we will have rational agents, right? So we're talking about rational expectations. We will also get back there what exactly that means, which, like for us, will then always mean these people, households, firms, they maximize utility, they maximize profits, subject to constraints, right? Subject to a budget constraint, for example, or a firm subject to a production function, right? So they are maximizing, right? That's the typical setting, right? Rational expectations is the typical thing. It's not like you always have to do it, right? You can deviate from rational expectations, that's doable, but like not in the models that I will show you, right? This makes stuff much difficult, but you can also do this if you're really not liking that, right? That's the general setting. Right? But there's two things that micro-foundations do not imply, and that's what I want to make really clear, right? Micro-foundations does not require perfect competition, right? So perfect competition is this idea, firms set prices completely flexible, free market entry, and so on and so forth, right? Firms of price takers. No market power, right? This is not what's like the core of our modern macro models, right? Actually, the core of the new Keynesian model that I will show you later is market imperfections, right? So frictions, right, is a very important thing, right? So just, I mean, what's the example for frictions, right? Incomplete information, externalities, market power, right? All this stuff will show up, right? Okay. And it does also not require this idea of a representative consumer or this idea of a representative firm, right? So the first models I will show you will have this for good reason, right? But if you look at what people actually do in current macro research, we're basically only talking about heterogeneity at the moment, right? It's really like the only thing, right? So like models with heterogeneous consumers and or firms. That's really like the thing, right? And we do this in models based on micro foundations, right? So my message should be, I might be torturing you with some models here, but you may also be thinking on these stupid assumptions, right, about representative consumers, for example. We'll say, yes, it's true, right? But understanding these models is basically the crucial thing for also doing the other part later, right? Because they're all built on this. They all come out of this function. Yeah, and I mean, maybe just to flag that, because I know that many people probably have heard this word, right? What is a DSGE model, right? So this is these modern macro models, right? Just to explain where this comes from. So micro foundations will basically always imply that you have to deal with dynamic models, right? Just think about this consumption choice, as I just said, right? If I decide about my current consumption, I will worry about my income in the future, right? Because if I get a credit to finance my current spending, I need to repay that in the future, and this is where my future income, my future expectations matter, right? So this is why models with micro foundations are typically dynamic. And this will basically, like in the first part of the course, occupy us, because like making these dynamic optimizations is one of the techniques I kind of have to torture you with, right? How do we actually do this, right? And ISLM is completely static, right? There's just one, there's not even a T, right? There's just one period. You're not even thinking about what that means. Is that a year? Is that 10 years? All this doesn't play any role there, right? You can talk about this in this model. In these models you can, right? All right, and then in these models, in the DSGE model, what you typically think about is shocks, right? You think about exogenous stuff happening in these models. In particular in the short run, if you use it as a business cycle model, right? Which often implies that we will consider these models as stochastic, right? And again, ISLM is typically all deterministic. We all know what's going on. There's no real role for expectations, right? But once you have stochastics and you have randomness in, right? This is really when expectations will matter, right? It's also when uncertainty will suddenly matter, right? And in ISLM, all this doesn't show up, right? So this is where the S comes from in DSGE. Again, I mean, not every model is stochastic. In particular, growth models, not necessarily. This is why I put this in parentheses here, right? But typically, we have a DSGE, sometimes we have a DGE, right? Right, and I mean, it is a macro model, right? So in the end, you will always have different markets going together. So this is basically the general equilibrium, right? So this is the GE, right? And this is what a DSGE, dynamic stochastic general equilibrium models do. So in that sense, right, these Lucas critique, these micro foundations, bring us to these Gs, right? Just to say. So yeah, and that kind of, I mean, just to have everybody on the same page, right? So what does that mean here? What am I doing here? Am I doing classical economics, neoclassical economics? Is that neoliberalism that we're doing here? What are we doing? Or is it Keynesian economics? I would actually say it's both, and it completely depends on what you do in your model, right? You can do all of that, right? It's completely up to you. So just to make that clear, right? So this idea of micro foundations, right? This modern macro, it basically goes back. There's a very famous paper that we will also discuss, Küttler, Prescott, A2. This is classical economics, right? So this is really this, right? Which is basically a different word to use would be supply side economics, right? This is what it is. Thinking about profits, thinking about maximization, right? But the reason why this has been, I mean, you could also call this mainstream. Why has this become mainstream macro? Well, because it's actually super flexible, right? I just said you can put in multiple frictions, right? And this is exactly what we do, right? So a Keynesian or new Keynesian way of thinking about this would be you take these classical models, right, which will be an RBC model, for example, which I will show you, and then you put in frictions, market power, for example, price frictions, rigidities, right, inefficiencies, right, and then you get actually a pretty important role for demand side policies too, right? So these Keynesian multipliers, right, the Keynesian plus, this all shows up in these modern macro models, right? Obviously to different degrees, right? I mean, in your models, as I always said, right, a model will always stress one mechanism and then put one maybe aside, right? So it's completely different how you set up your model. Once the one is more important compared to the other, right? But this is super important, right? So these demand side economics, these Keynesian ideas, it's basically, it's all over the place, right? Exactly in these models, right? This is kind of why I'm not a big fan of these school of thought and macro, because I always feel like it's a bit, we can actually do really a lot with these models, right? And that's kind of also how I want you to understand these models, right? These models are tools. And if you know how to work with these tools, you can actually do so many things with these models, right? So many policy relevant things. And this is kind of what I want to, right? And that's my understanding of that, right? Good. Questions, thoughts?
Remember on one of the slides before you said something about that there's a problem with heterogeneity or something? Can you elaborate
Yeah.
on that?
What that means? So basically get back there too, but in a standard model, I should say standard macro model, also the first one that I will show you, where we have micro foundations, we will have the idea, for example, of a representative consumer, right? So you think of a household, and you basically take this one household as representative for the whole economy, which is basically then always important because, as I said, we will go from micro to macro, we want to aggregate again, right? So we basically treat this one representative consumer as the guy determining the whole aggregate economy, right? And I mean, that critique has been around for ages, right? Maybe this idea of a representative consumer is not very useful, right? So some models are useful, maybe some are not, right? Because obviously the representative consumer doesn't exist, right? I mean, some of us are very rich, some of us are very poor, and depending on how your savings, for example, right? I mean, rich and poor is just for me a different way of saving. Some even have negative savings, some are highly indebted, right? You will make very different consumption choices, right? So in that sense, you could say this representative consumer doesn't exist, right? Which is true, right? As I said, every model is wrong, right? This is clearly wrong, right? The question is, does it matter? I mean, this is kind of going too far, but I mean, this is, let's say, the most latest, if you want to call it revolution in modern macro, was really to move away from this representativeness idea, which happened, I don't know, 10, 15 years ago when this became really big, right? I mean, there's papers already doing that going back to the 80s, right? But nowadays, we are really good at doing this, right? So we basically know how to move away from representative agents, right? And what has been shown like 10 to 15 years ago is that this heterogeneity matters, right? So, I mean, if you write down a model, I would always say you can buy any assumption if you're confident that your assumption doesn't change your main mechanism that you're worried about, right? But here, 15 years ago, people have argued, actually this assumption is crucial, right? So for example, for the effects of monetary policy, we nowadays know that basically the inequality in your country will affect the pass-through of monetary policy, right? And this is something that only a model of heterogeneity could actually explain. Right? Yeah. Does that explain your question? Sorry, I mean, this is the thing. I will also get back there. At some point, I will talk a bit about heterogeneous agents. Problem is, this is like technically too advanced for this course. So I will like repeatedly point out what that means. Also give you some papers. I cannot show you more heterogeneous agents. I just have to do like start with the first thing first. But I just want to flag that this is super.
So how is this problem approached?
How it is approached?
How do you check the heterogeneity?
So I mean, we will talk about basically my first half of the course, right? I will first of all talk about dynamic optimization, and then we will talk about how we actually solve these dynamic models, right? And you will see that solving these dynamic models very often requires exactly this, right? So if you move away from the representativeness assumption, solving these dynamic models becomes a mess. Again, nowadays we know how to do this. 15 years ago we didn't know how to do this. Nowadays we do know. So it's basically a technical thing, right? How do we actually make these models approachable to heterogeneity, right? So this is, again, a question. This is also a question of math, right? So we actually need to understand how we do this. Very often these models can only be solved using simulation techniques, right? This is also like why I asked you to open MATLAB this week, not because I want you to simulate models, but our computers do this in the end, right? It's not like we can actually solve these models by hand, right? I mean, in ISLM, this is also when you teach it in an undergraduate, you can in principle, right? You can write down these equations and compute an equilibrium. Here you typically cannot, right? So this is just a very different. But it's really the thing that we do, right? So, I mean, basically, wherever you go nowadays on a macro conference, it's always about heterogeneity. Just like, this is exactly what we do. Good. But yeah, it really comes all out of this, right? So let me use my last 15 minutes to throw you back into the Solo model, right? So who of you has seen the Solo model? So for those of you who've not seen it, maybe we just look it up again, right? I will be a bit more detailed compared to the ISLM. Maria will also do that in the exercise class in detail, because it really turns out that much of the stuff that we do here, we will also be doing again in the neoclassical growth model, right? Which comes later. Difference is, the Solo model is not micro-founded. But I will show you exactly, based on the Solo model, where we introduce the micro-foundation, right? So where does it make a difference? Okay, yeah, so this goes back to this famous paper by Solo, which is super old, right? I mean, here, this model has become super influential, right? But it's not necessarily because of the economic content of the model. We actually show you later, actually this is not a very good model for understanding economic growth, we should get there. But it is kind of the most important model for like, which all our current macro models build on, right? And this is why this is so important, right? Good. Why is it so important? Because it is actually a dynamic model. I don't know how you've seen that in the undergraduate. If I teach that, I typically avoid saying that because I scare people away. But here I will now point that out in detail, right? So why this is actually a dynamic model. This is already there, right? So if you understand the solo, you kind of know a bit how dynamic model works, right? Why is it dynamic? Because it is a model of capital accumulation, right? The solo model is all about capital. It's all about this, right? How much do we invest? How much is depreciating? And how does the capital stock of the economy evolve over time, right? So it's really this model of capitalism, right? Why is capital so important, right? So what's the difference of capital and labor? Capital is what we call accumulable, right? So labor is, you can like go out in the morning and you can work a full day, right? But basically all the work that you did, roughly speaking, is then gone again, right? Maybe you were like very productive on that day, that's nice, but it's not like the labor input that you used on that day, you can use again on the next day, right? But you have to like go out of bed again in the next morning and have to walk again, right? This is how labor works. Capital is different, right? If you invest in a capital stock, you have a machine, right? You buy a machine. That machine, once you've bought it, will keep working from day to day, right? This is what capital is doing, right? So in that sense, it's accumulable. That's what we mean by that, right? And I mean, I think this also explains why capital here is so important, right? So I mean, obviously capital does also depreciate, right? So first of all, machines, right, they're just not working anymore. Machines also need human beings, right? It's not like I'm simplifying, but that's the main difference, right? If you invest in a machine or if you buy a house, right, you can live in that house from that day onwards, right? It's a bit of depreciation, but it's there, right? And that's the main difference to labor. Right? And that's what we mean by this accumulable factor, right? And this is basically the core that Solo basically wrote down, right? In a model, right? It's not just this point, but it's basically how do we think about this, right? Okay, so I'm trying to show you here the most simple version of the model. Closed economy, constant population, one good, right? I mean, all this stuff can be changed, of course, right? Actually, these different goods is also sort of heterogeneity, right? I mean, these standard macro models, we just have output, right? Arkley would say we have very different goods, right, in the real world, which is true, and this also plays a role, but we just have one way, right? I show you a discrete time version of the model, which means I will be indexing time, so all my variables from now on will have this t index. And t is time, goes basically from 0 up to whatever you like. You can make it up to infinity, right? So you can think about this here as years if you want. We can also think about this as quarters or months or maybe days, whatever you like. But different, it's just different time periods, right? Don't be surprised if you open these textbooks. These textbooks very often do this in continuous time. I personally find continuous time much more difficult. Maybe I'm too simple-minded. I don't know if you like that, do that in your textbook. I just find the discrete time approach much more approachable. This is why I chose to do this. But in the textbook, this is typically different, so don't be surprised, right? It basically, like in terms of the model, will give you exactly the same. Just looks like you have even more math, right? So where I have a sum, they will have integrals. Good. Good. So yeah, this is the Solo model, right? So basically, I think here I've stripped it down to 1, 2, 3, 4 equations, right? And this is basically what you need to understand the Solo model, right? So we start with an accounting identity, which is here super simple, which is basically what I already gave you. Like this is basically isolate, right? Output equals consumption plus investment. There's no G, there's no NX because there's no government here, there's no net exports, right? I'm just setting these two to 0. Right? So this is basically what I got, this accounting identity, right? Basically comes out of the national accounts. Right? The second important thing that you have here is this F function, and this is really typical of a Solo, of a neoclassical model, right? As I said, all these models come out of the classical tradition. This is really these production functions, right? This is a neoclassical production function. With this idea, we are producing this output by having capital and labor. And the typical thing that we do is to write down a Cobb-Douglas production function. Right? I know that students very often ask me, could you at some point do something different? Well, I mean, we could actually do something different, right? It's not like it wouldn't be possible, because you can write down many things. Point with the Cobb-Douglas is that it has some nice things that are useful and that they're also kind of in line with the data, right? The main thing being that this alpha things here, right? Maybe you've seen it before, right? If you look at these elasticities, right? This alpha coefficient here and 1 minus alpha here. In these type of models, they will in the end represent what will be equal to the labor and the capital share, right? And now remember these Calder facts. If you take this capital share of 1/3 as a fact, right, as many people did or do in this literature, would simply set this number here to 1/3, right? And this is exactly where this typical integration comes from, and then you basically already know that your model, you can do whatever you want, but this fact you will match, right? So this is one of the reasons where it's come from. And the second thing, that you have this decreasing, increasing, but diminishing returns, right, to every factor. And if you want, and that's the way how I put it down here, you actually have constant returns to scale, which are super important in this type of model. So these are these typical attributes that we want a production function to have, and that's why we use the Cobb-Douglas, because it has all these attributes. Right? Actually, that's the way how Cobb-Douglas, there's actually two persons, right? Cobb and Douglas, why they created this production function, right? That's basically how they started, right? Let's find a production function that matches all these facts. This is what came out, right? So this is no coincidence, right? Okay, good, this is this, and then the other two, right? What else do you need? And now this is kind of the equation of capitalism now, right? Is my capital accumulation, right? This is what I just already gave you intuitively. Here's an equation, right? This is my capital stock, right? So my capital stock tomorrow depends on today's capital stock minus a certain share that depreciates, right? That's your share of your machines that you have to throw away because they're just too old, they're not working anymore, right? Typically assume that this is a constant rate. Plus whatever machines you buy in addition, and that's what we call investment, right? And see how labor is different, right? I mean, here I'm also taking labor, I just actually take labor here as constant, because labor basically, you need your population every day again and again to go like, right, in the morning and go to work, right? And this is, right, obviously different with capital, right? Once your machine is there, it's there, right? Okay, so in that sense, it's accumulated, and this is exactly the equation that leads to that, right? And then the last thing you need in order to close this model, and then you're really already done, is just to say, okay, now I need some form of behavior, right? Actually, this model is already like defining many things, right? So let's say you start in one equation in one period 0, you have a certain capital stock. Now assume you know what investment in that period is. Then you will know the capital stock in the next period. If you know the capital stock, you actually know what's produced. Right? Then you can compute what is consumption, what is investment, and then you can also compute the capital stock in the next period. And that would mean that you also know what is output in the next period, what's consumption in the next period, and you're basically done. Right? So how do I know what is consumed, what is invested? And this is exactly where Solo is now reduced form, right? So this is now not microformat. So what Solo just did is basically following the ISLM, right? Just assume that investment is a constant share of production, right? So where like in this Keynesian world, I said consumption is always this constant share of input, of disposable income. Here I'm just like reversing this and saying, okay, investment is always this constant share of production, right? So that's really assuming behavior, right? I'm just putting that in, right? Households could behave very different, right? But we're just assuming it. And this is now, let me make this as the last point. This is now forming what we call a complete dynamic system, right? And that's the part that I always spare the undergraduate students, but here now you see it, right? Start in some period K0, right, with some initial capital stock. Then you can compute investment in that period, right? Once you compute investment, you can here compute production in that period. You know what's produced in your economy. If you know what's investment, what's consumption, you can compute these two. And then from this equation here, you can actually compute the capital stock in the next period. And then you just keep doing, right? You do that in period 1 and period 2, 3, 4, basically up to infinity, right? Your economy is set, you know what's happening, right? You're completely describing your economy. And basically, I mean, the way to how we typically do this, and this is exactly what Maria will show you in more detail, is just put these equations one into the other, right? It's in the end really just putting one into the other, right? So what I do is just take this one here and put that in equation 5. Right, sorry, let me just finish this, right? Put that in here. And then you get this equation here, right? And this is really the crucial one, right? Why is it particular? Because it only depends on K, right? So what we do is only on capital, right? So we're basically taking out of the model all equations, all variables that we do not necessarily need. We strip it down to just one variable. And I mean, as I said, this is the model of capitalism, right? So it all depends on capital. Here, all the remainder is basically completely irrelevant. It all depends on capital and this capital accumulation. And now, I mean, I will basically spare you that probably for next week, right? But I mean, if you look at this equation here from a mathematical perspective, this thing is not easy to solve because this thing here is what we call a difference equation, right? It's a dynamic one. You have kt plus 1 here and you have kt here, and it's actually even worse than that because it's a nonlinear difference equation. Why is it nonlinear? Because you have here this f, right? F is your production function. This is not a linear equation, right? So I mean, you get back to this, right? But I mean, if you ever like, you know, so I don't know, open any YouTube videos, right, on difference equations, what the typical math textbook tells you is solving difference equations for linear systems. That's relatively doable. For nonlinear, it's actually even a bit more involved, right? And this is basically whenever you work with dynamic models, you will have to do, right? And this is one of the things that I will talk about. Right. Okay. Good. Questions? All right. So then we continue here next week, and then Maria will also cover that in the exercise class. So I just to say that clearly, this is important, right? So if you go there and discuss it because you can talk much more in detail about this, right? Also about these convergence and stuff. We will also get back there next week. So have a good day, and I'll see you next week.
Ja, eigentlich ist es also gut für dich. Aber ich will jetzt jetzt